Welcome to the module number 4, that is classification module, and in this lecture we are discussing about Naïve Bayes algorithm. We'll understand how Naïve Bayes algorithm works, we'll understand all the maths behind it. So what exactly is Naïve Bayes classifier is? It basically follows the Bayes theorem and calculates the probability of an event occurring with the probability of another event that has already occurred. That is, we have to predict that what is the probability of event A given that the event B has already been occurred. So using this formula, we will predict the data set and will say that yes, this given data instance belongs to this class or not. So let's see how. Suppose we are given this data set, and in this data we have these parameters: age, income, student, credit rating, and we have to predict that whether this person can buy a computer or not. So this is the outcome, and these all are the parameters that we have. So using these four parameters we have to predict whether the person can buy a computer or not. And the data instance that we are given is age less than equals to 30, income medium, student yes, credit card rating fair. In case of age, we have three different parameters, that is less than equals to 30, 31 to 40, and then greater than 40. These are three different data we have in case of age. And in case of income, again we have three classes: high, medium, and low. In case of student, we have two different kinds of classes, that is whether a person is student or whether a person is not a student. So either no or yes. And the credit card rating, again this is uh, having two classes only, that is fair or excellent. So we have to predict that whether a person can buy or not. So let's see how we can do this. So this is our data. Now, step number 1, we will calculate the probability of the outcome. So the person can buy a computer or not. So what is the probability of yes? We have, let's count the total number of data sets we have. So total we have 14 entries, and yes, let's calculate yes. 1 2 3 4 5 6 7 8 9. So the probability of buying a computer, that is whether this label is yes or no, it is 9 by 14, which is equals to 0.643, and the remaining 5 entries belong to no. So the probability of no is 5 by 14, which is 0.357. Now what we have to find out, we have to find out these four parameters, right? So what we'll do is we'll find out the probability of these four parameters with respect to the condition whether the person can buy or not. So probability of age less than equals to 30 given that a person can buy a computer. So in this case what we'll see is we'll see that age should be less than equals to 30 and the person can buy a computer. So here in this case age is less than equal to 30 but the person cannot buy a computer. Age less than 30, no. Age less than 30, no. Age less than 30, yes. Age less than 30, yes. So we have two instances where age is less than equals to 30. So the out of total yes, we have only two outcomes in which age can be less than equal to 30. So it is 2 by 9 and the probability is this. And again we'll calculate this age less than equal to 30 with respect to no. So it is 3 by 5 because we have only three parameters, 1, 2, and this third, in which age is less than equal to 30 given that a person cannot buy a computer, right? And implying it to the formula, we find 3, that is yes, a person cannot buy a computer and the age is less than equal to 30 by person cannot buy a computer, that is 5. So this is the probability. And for other parameters, medium, income, student and credit card rating, we again follow the same steps. So income equals to medium and we have to look for yes. So income is medium here, yes 1, medium no, not counting, medium yes counting, medium yes counting, medium yes counting. So we have 4 entries by now 9 because we are taking case of yes. So 4 by 9. For no, this is 2 by 5. And for student we'll again see that yes student and yes, 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 and again yes, 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 yes. So we have 6 by 9 entries for a student being for a person being a student and affording a computer. So we have 6 by 9 and this is our probability. So this is how we will calculate all the probabilities of the data set that we are concerning about. Now we have to find out that whether if a person has all these parameters, can that person buy a computer or not. So what we'll do is we will calculate it using this formula. So first of all we'll calculate that yes, a person can buy a computer having all these parameters. So if age is less than equal to 30 and a person can buy the computer, the probability is 0.222. Income is medium, probability is 0.444. Student is yes, probability is 0.667, and credit card rating is fair, probability is 0.667. So we will multiply all these 4 probabilities and this will be the total probability. This is I'm following the rules of probability. So this is I am multiplying these probabilities and this is the final probability that yes, a person having all these 4 parameters and buying a computer. So the probability is 0.044. And again for case of no, I am taking the instance where I have these no cases. So 0.6, 0.4, 0.2, 0.4, right? And again I am finding out the probability. And now finally this probability we are multiplying with the actual probability of buying yes or no, applying the formula. So I'm multiplying 0.044 with 0.643. So this is my probability. And then again I'm multiplying this probability with no and I'm getting this result, right? So this is how we find out the probability, and in case of yes we have a higher probability as compared to the no. So we'll conclude that if a person has all these parameters, then yes, a person can buy a computer, because the probability of buying a computer is higher than probability of not buying a computer. So we'll assign this data set to a class of yes, that yes, this person can buy the computer, right? So this is how a naive Bayes algorithm works. It's very easy when you understand the maths, and in the next coming lecture we will hands-on this problem with the Python code. This particular model works on the probability formula of Naive Bayes, and we'll be using a Python code to implement this model and we'll classify using this. So let's see how to perform it. So I am using the basic libraries, that is pandas, numpy and matplotlib. Okay, and the dataset I am using is a study data where we are given few parameters and we are checking the knowledge level. Okay, so we are using 2 parameters, repetition time, study time, and we are saying the knowledge level of a person. So we have 2 knowledge levels with us, that is whether it's low or high depending on the time of study and the repetition time. Okay, so let's check the data info as well. So we have 258 data entries with us and none of these entries is null. Okay, and also we can check the class using the unique label as we have done in the previous lectures also. So knowledge level dot unique. So we have 2 classes, low and high, and let's check the data distribution in these 2 classes. Okay, for that we use value counts. Okay, So we have 151 entries in high class and 107 entries in low class. So which is a pretty well distributed data. We can work over it. Okay. And now we'll split our data to training and testing, but first we'll split our data to input and output. For that, for the input part, what I'll do is I'll drop the column knowledge level. So what I'll do is data.drop data dot columns, and I have to drop the second column, that is the third column actually, and we have to drop the column, so we'll mention the x is equal to 1. The output will be data and the column knowledge level. Wait a second. Okay, so we have our input and output with us. I can show you the input we are using. So that's the input we have. Okay, and now you can see that our output value has categorical data. So to deal with this categorical data, I am using getDummies, as I have explained in the previous lectures as well, how to deal with the categorical data. So in the same way, I am using getDummies function, and then I am passing on my data. So data columns equals to knowledge level, right? Okay, it's a spelling mistake actually. Yeah, so we have our output with us. Now let me show you the output that we have. So that's the output we have actually, and now basically we have performed it over entire data, so it's taking again the entire data with these two columns, but we are only interested in either of these columns, knowledge level high or knowledge level low. So let's use knowledge level high as our output, right? So what we'll do is now we have to split our data. So from sklearn dot model selection import train test split, right? And then xtrain comma xtest ytrain comma ytest equals to train test split. Now the input is x and the output will be this particular column of y data, right? So we have again it in the numeric form. Now we have to set the test size. So let test size be 0.25 and then random state be 0. So we have our 4 components with us. Now the data we have will scale this data so as to be sure that we have a similar distribution of data. Okay, so for that what I'll do is from sklearn dot preprocessing importing standard scaler. You have seen this before, so let's scx equals to this standard scaler initialized, right? Then xtrain equals to scx dot fit transform xtrain, right? xtest equals to scx dot transform xtest, right? Okay, so here we go, we have scaled our data. Now it's time to train our Gaussian Naïve Bayes model. So for that what I'll say is from sklearn dot Naïve Bayes import Gaussian Naïve Bayes and let's name it as NVB equals to initializing this Gaussian Naïve Bayes model, right? And now we'll train our model. So we'll say NVB dot fit X train comma Y train. Okay, I have done a spelling mistake actually, so it's Gaussian NVB, right? So we have trained our model. Now we'll predict the data we have. So for that we'll say y predict equals to this NVB dot predict, what to predict, X test values. Okay, so now we'll build our confusion matrix. This is our confusion matrix. Let's check the confusion matrix result. So you can see that's pretty good. Now we'll also check the accuracy we have with us. So Naïve Bayes is classifying this data set with a probability of, with an accuracy of 93.85%, which is a pretty good accuracy. Now we'll also check the hyperplane that our model is building up so as to differentiate the classes. Okay, so for that I'll be using the matplotlib. Okay, so let's plot the model over the test data we have that it has predicted. So we'll say, let's name it from what we'll do is we'll use matplotlib and we'll use mesh grid so as to plot this hyperplane or the decision line so as to see that how our model has classified our data. Okay, so for that we'll use from matplotlib dot colors. We'll import the listed colors. Don't worry, we'll see how all this work. Listed color, sorry, map, right? And then we'll say let's set is at x set, then y set equals to x test values and y test values. So we'll assign these values to x set and y set. Now what we'll do is we'll set the coordinates x1 x2 using the mesh grid. Okay, so basically what mesh grid is, mesh grid returns the coordinate matrix from a coordinate vectors, right? It is basically used to create a rectangular grid out of two given one-dimensional array. Okay, so what it basically returns is it gives us a rectangular grid out of the two given one-dimensional arrays. Okay, so basically we'll be finding out the coordinate matrices. Okay, so we'll say np dot mesh grid, and then we have to pass on, so np dot a range, that is the range of the array we have. So start point will be the x set that we have already created, and we'll be accessing the first column, right, dot minimum, that will be the start -1, and then the stop will be the x set all the rows 0th column and the max value, so dot max, right? This will be the start and stop +1. So step equals to, let's set it to be 0.01. So it will create the x1 x2 coordinates using the x set, that is the x we have the x test values with us, and using these values, the minimum and maximum values, it will create up all these x1 and x2 values. Now x1 is created, and now we'll create our x2 value. So for that what we'll do is we'll say, okay, so we'll again copy this thing copy. Now for, wait a second. Now for x2 values, we'll say, we'll find the exit values, but then the first call, okay. Yeah, and keeping the step size to be same. So closing it over here. Okay, wait. Yeah. Right. So now we have our x1 and x2 values with us. Okay. Yeah, right. So first entries, that is the reset time, will go to x1 and the x2 will go to and the study time will go to x2. Now what we'll do is we'll use contour function so as to draw lines and fill the contours so that we can see which region belongs to which class, right? So for that we have a function contour f. So what we'll do is we'll say plt dot contour 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 f. Okay, and then we'll pass on these values, so x1 and x2, and the hyperplane that it's giving us is using the nvb dot predict. So nvb dot predict. So since we have columns, so we'll use a rival function so that we can have a continuous array. So we'll say we'll be predicting np dot array, and then we'll be passing our x1 dot revel, right? These are the x test values. Okay, so x1 dot revel and then x2 dot revel. Right, and then coming out of the np dot array, we have to predict this. Okay, and then what we'll say, we'll transform these values and then we'll again reshape it. Right, and we'll reshape it to the forms that x1 dot has. Okay, you don't worry about this, it's a bit complex. You just understand when I'll show you the visualization. If you can understand this, then it's very good, but otherwise just focus on the visualization that I'm going to give you so that you can understand how your model works. Now we'll set the alpha parameters. So alpha equal to 0.75, let's say. Don't worry about it, just see what I'm doing. And then the color map I have to set. So here we use the color map we have. So listed color map, and then we have to choose. Okay, wait a second. Listed color map, and then we have to choose which two colors we want. So here what we want is, we want two colors. Let it be white, so that you can see the change in the class or change in the hypothesis when we'll be building it up. White and then gray. Okay, so here we go, and now we have to set our limits. So x lim equals to x1 dot min and x1 dot max. Similarly y limits, so y limit be y1 dot min and y1 dot max. Sorry, here we have x1 x2, so x1 dot min, x1 dot max, and then x1 x2 dot min and x2 dot max, right? Because we have these values over here, x1 and x2, right? So x1 will be the value we have in column 1, that is the repetition time, and x2 is the values that we have in the column 2, that is the study time. Okay, and now we have to plot all the data points we have. So for that, what I'll use for I comma j in enumerate function. Okay, and then I put up np dot unique y set. Okay, so based on all these unique values, we have the iteration performed and we'll be plotting all these values. Okay, so we have the total values based on this. So x set will set the where y set equals to j 0. Okay, so we're taking the x set and we'll say y set equals to j comma 0, and then we'll say x set values where y set equals to j, but the x is be 1. So this is how we take the x and y correlation with us. Again, we have to use the color map. Okay, so we'll say for the data points I'll be using red and green colors. So again, copying this, right, and red and green color. Okay, and this will be set according to the row index we have, and the label be j, that is the predicted outcome, right? And now let's set the x label. So x label be r time, that is repetition time. Similarly, y label be s time, study time, and then plt dot legends, and then plt dot show, right? Okay, wait a second, I have used y set over here. It's actually y set only. So you can see this is the hypothesis we are getting up. You can clearly see that here we were getting this wrong value over here. We are saying 4 values to be wait a second, 4 values to be 0, right? 4 values to be 0, but they were actually 1. So that was the data wrong that was the wrong part of our model. We were classifying 4 data points as belonging to different class, but they are actually belonging to class 1. What we are saying, they belong to class 0. So you can see that as per the confusion matrix, we have only 4 points marked wrong. That is, they actually belong to class 1, but we predicted them as a part of class 0, but they were a part of class 1, right? So this was the error in our model, and you can clearly see that there we have 4 points, which this hypothesis should be like this, going over here, and then it should be like this, but it's going like this, and it's saying that these 4 points belong to class 0, but actually they are not. So what we have done is we have plotted all these data points based on the class it has, and we have plotted this contour based on the prediction I am making. So here I am in contour case, I am predicting the value and I am plotting it using that, right? So this contour is the prediction contour, and this was the actual data points we have in x test value, and you can see that this contour is the prediction hypothesis, and it's classifying 4 data points to be wrong as in the confusion matrix. So now I guess you guys are very clear about how our model works, how the error or how accuracy is defined, right? So this was all for this lecture. Best of luck and keep following.